Hello, I welcome you all in this course on steam and gas power systems. Today we will discuss water tube boilers. There are number of water tube boilers. We cannot discuss all of them here, but we will take certain water tube boilers like Stirling boiler, Babcock's and Wilcox boiler, and package boiler. Now, Stirling boiler consists of a number of drums, right? They are steam drums. So, a typical Stirling boiler has 3 steam drums, right? And one is water drum or mud drum. Now, this water drum, it can have 4 or 5 also steam drums or 2 or 3 water, depending upon the size of the boiler, amount of steam is required, because a typical Stirling boiler can work up to pressure is equal to 60 bar, and steam generation rate can be 50,000 kg per hour. It is enormous steam generation, it is a huge boiler. Efficiency of this boiler varies between 60 to 80%. Okay, it can go up to 80% efficiency, right? So, let us take a typical of 3 steam drum boiler and 1 mud drum boiler, and these drums are connected with bent water tube. Bent water tube. Now, these bent water tubes, they connect drums, all these steam drums to the mud drum. So, they are steam drum 1, 2, 3, and this is water drum or mud drum. It is ensured that the water level in these drums, drum 1, this is drum 1, this is drum 2, let us say this is drum 3. Water level is maintained same in all the drums. Now, how it is possible? It is possible when we put circulating tubes between these two, or these two drums are interconnected. They are known as circulating tubes. Okay, and another type of tubes are equalizing tubes. They are for equalizing the pressure. So, these are equalizing tubes which are connecting all these 3 drums, and these 2 drums are connected by circulating tubes. Now, feed water is provided from here. There is a feed check valve, and feed water is provided from here, right? And from here, the feed water enters this water drum, and the length of the drums perpendicular to this, I mean, just to give you an idea, this can be approximately 5 or 5.8 to 6 meters, 5.8 meters, and the diameter of drums is approximately 2 meters. So, size of the boiler is quite large. These tubes are bent tubes. The benefit of the bent tube is thermal stresses are not developed. They will simply bend. When the expansion takes place, these tubes will simply bend. So, thermal stresses will not be developing in these tubes. Now, it is put in a housing. And some provision for, I will show you a photograph of this. This is, the arrangement is something like this. Is on river side. I have taken this from, in this case, the feed water is supplied from here. Now, whatever is given in the photograph, feed water, feed check valve is here, and feed water is supplied from here, right? And the fuel is burnt here in this part. This is also, the top is also closed. Fuel is burnt here in this part, okay, and there is a ash pit. The rest of the things are more or less same. Fuel is burned here and it is passed over these tubes. Feed water comes from here, it goes down and it comes to the water chamber or mud chamber, and after this the water vapor, when the water is converted into the vapor, it starts rising and getting collected here. Now these drums, they have mountings like pressure gauge, water level indicator, safety valve, steam stop valve to supply the steam. Now if you want to superheat the steam, then simply take steam from here in a pipe and again circulate through this space, right? So the steam will get superheated. Similar type of arrangement is done in most of the boilers. So the flue gases, they get deflected from, they are baffle plates. So baffle plates are also shown here. So flue gases coming from here, they do not simply cross this. There are baffle plates I will show you by different colors. So they are baffle plates. So flue gases, and this will come here. So there is a baffle here, and in this case the flue gases emerging from here, they will enter from the top, they will come down and then leave from here. So there is a path of the flue gases is maximized with the help of these baffle plates. Steam is collected here. Now the benefit of this Stirling boiler, the major benefit is high steam production rate. I'll write the benefits here. The biggest advantage of this boiler is mass or steam production rate is very high. As I stated earlier, it can go up to 50,000 kg per hour. That is the one thing. Now second thing is the pressure can also go up to 60 bar, and pressure loss in the entire system, because it works on the natural convection, right? And in fact the movement of water takes place by the principle of thermosiphon, right? So the pressure drop in the boiler, within the boiler, is minimum. That is another advantage of this boiler. And this boiler permits a great flexibility in the design. I mean, you can, as per your requirement, you can change the design of the boiler. You can go for, say, 6 drum boiler and you can add here 3 more drums, right? Tubes, they are bent tubes. Because they are bent tubes, that is why no thermal stresses are developed inside the tube. That is the benefit of this tube. But the problem with this boiler is it is very difficult to clean this boiler, because there is a network of the tubes, right? So cleaning is a major problem. Manhole is provided on this side. So for the cleaning purpose, manhole, this is the great side. So this side, for cleaning purpose, the passages are provided to clean the boiler, but cleaning a difficult job. It is large in size, so it occupies, definitely if you want more steam, so boiler has to be larger in size. So it is larger in size, it occupies more space. Thirdly, superheating is also, we cannot go for very high level of superheating with this type of boiler, but this, where the requirement of steam is large, this boiler is very useful. Now after Stirling boiler, we will take the Babcock's and Wilcox boiler. This is also a very popular boiler. This boiler is also a water tube boiler, and this boiler is also quite large in size. This boiler has a horizontal shell at the top. As shown here also, right? It has straight tubes inclined at a particular angle. They are water tubes, and at the both end a water header is made. Water header is made for the circulation of water. The inclination of these tubes is 15 degree from the horizontal. It is also housed in a brickwork, right? Water entering in these tubes, the feed water, it moves in upward direction. This boiler has a grate. Most of the arrangement are same. It has a grate, right? Fire, the fuel is burned inside, and then there are baffles here also. In this boiler also, there is a provision of baffles. So the purpose of providing baffles is when the flue gases they move over the tubes, they move in a zigzag way, and they cover the maximum path. When they cover the maximum path, the heat transmission is maximum, so the efficiency of the boiler is improved. Steam generated in the boiler goes to the shell, and shell is, as in the other case also, shell is partially filled with the water and partially filled with the steam. So this lower part is filled with the water and upper part is filled with the steam. Now suppose I want to have a superheated steam. Now in order to have a superheated steam, the steam is trapped with the help of, or we can make a trap here also. Just steam is taken from the upper part of the shell. It is recirculated in the boiler body and it is taken out. So steam, the saturated steam which is collected at the top of the shell, it enters this tube, circulated through this tube and leave from the top, and this is the supply line for superheated steam, and heat for superheated steam is provided by flue gases flowing inside this, because the entire shell, this entire space is filled with the flue gases, and this part you are saying, this bent tubes, they are for superheating of steam, right? And the water to these tubes come from this side. So this is how the entire system works. Now this boiler can produce 20 to 40 tons per hour of steam, 20 to 40 tons per hour of steam at in a range of 11 to 17 bar pressure, right? In this boiler, because it also works on the natural convection, the pressure loss is minimum. Defective tubes, because there is a lot of space inside the shell, inside the boiler housing, so defective tubes can be easily replaced. So defective tubes can be easily replaced. It is supported, the entire system is supported on the iron structure. So the problem, because what happens when the system is supported or it is restricted by the brickwork, right? In that case, the structure related problems do come into the picture. That does not happen when the entire system is supported on iron structure. So these are the details of Babcock's-Wilcox boiler. After that, we will take up package boiler. Now package boilers are, small capacity boilers. They are compact, portable, and they are available in a wide range, right? Wide range of steam generation and wide range of pressure. Now in most of the boilers, in these boilers you must have seen that there is a single pass of water tube. In package boiler there is a multi-pass. Now what we can do in a shell, just water is entering from this side, then it can take U-turn and return to same side, then again there is a U-pin and then again it can take U-turn and leave from this side. Now this will make the size of this will reduce the size of the boiler. So package boilers has everything inside one structure, one entity. It is smaller in size, it is portable, it is flexible. Flexible in the sense it has wide range of operations. Though you may have to purchase different boilers for different ranges, but packaged boilers are available in a wide range. Now in packaged boilers, if you look at the arrangement of the drum and the tube, there is a D type arrangement, there is a type arrangement, and there is a O type arrangement. In principle, there is a steam drum and there is a water drum, right? And the steam drum is connected with the water drum. And there are D types of tubes like this, curved tubes, in which the water flows and the flue gases are blown over these tubes, right? And the water and the steam, the water is converted to the steam, and the steam is collected in this shell. Another type of arrangement is A type arrangement. In A type arrangement, there are two water drums and one steam drum. They are connected like this, right? Another type of arrangement is O type arrangement. O type arrangement, there is a steam drum and water drum, and steam drum tubes are simply connected with the water drum tubes. So there are different configurations of steam drum and water drum connectivity in these boilers. In addition to this, you can use variety of fuel for this boiler. For this boilers, package type of boilers, you can use light diesel oil. You will find package boilers working on furnace oil, right? And different type of fuels can be used for these type of boilers. These boilers, the characteristic of these boilers is they have small combustion space, and heat release rate in package type of boilers is quite large. Efficiency also for these boilers, because they are compact boiler, efficiency of these boilers is also quite high. So I think we have covered a quite number of boilers. We have covered fire tube boilers, we have covered water tube boilers. Before we start mounting and accessories in the next class, I will give you introduction of mounting accessories. So mountings are those devices which are necessary for the operation of the boiler. For example, safety valve. A boiler cannot work without safety valve. Feed check valve. Now feed check valve is provided at the inlet of the boiler, right? It is a sort of non-return valve, and in feed check valve, the reverse flow of water cannot take place. Once the water enters the boiler, there is no reverse flow. Water level indicator I have discussed earlier also. There is a water level indicator. There is a pressure gauge. They are mountings only. And safety valve. Steam stop valve. There are certain accessories. Accessories are provided in a boiler to improve the efficiency of the boiler, like economizer, air preheater, feed water preheaters. So these are the accessories, and there are certain other accessories also which are necessary or which are required or which can improve the efficiency of the boiler. But the mountings, without mountings, boilers cannot be allowed to operate. Now in our country, there is a IBR Act. As per IBR, any steam generating machine which is having volume more than 5 gallons, 5 gallons mean 5 into 4.5409 liters. 1 gallon is this is British gallon. There are two types of gallons. One is US gallon, another is UK gallon or British imperial gallon. US gallon is 3.785 liters and British gallon is 4.5409 liters. So if you take 5 this gallons, so it comes around 22.7. So any steam generating equipment which has volume more than 22.7 liters. Now this limit has been increased to, or it is rounded off to 25 liters. It is subjected to the inspection by statutory bodies or state government bodies. Regular inspection has to be made before operating this boiler, otherwise boiler will not be allowed to be operated. If the volume is less than this and the boiler is operating very high pressure, it is not covered under IBR. These type of boilers are known as non-IBR boilers, right? For petty application, for small applications, non-IBR boilers are preferred, where the volume of the steam inside the boiler is less than 25 liters. For steam supply, suppose there is a pipeline for supplying steam. So if the diameter of the pipeline is more than 10 inches, it is again subjected to be inspected under IBR. So it's a very, I mean, it's a thick document or a very large document, and one has to be thorough before operating any boiler, because boilers are covered under IBR, and IBR was formed in 1925 because during that time there were number of accidents in boilers because not doing proper keeping of the boilers. So due to these accidents there were number of casualties. So an act was brought. This is Indian Boiler Regulating Act, Regulatory Act, and under this act, if the boilers are meeting certain requirement, they are put under inspection of statutory bodies. Now in the next class I will start with, I will continue with the mountings and accessories in the boilers. That is all for today.